Understanding Chaos Theory through the lens of Edward Lorenz. Welcome back to our channel. Today we're diving into the captivating world of chaos theory through the lens of one of its pioneers, Edward Lorenz. You might be wondering, what exactly is chaos theory? Well, it's a fascinating branch of mathematics and science that explores how small changes in initial conditions can lead to vastly different outcomes. This phenomenon is often illustrated by the famous butterfly effect, which suggests that a butterfly flapping its wings in Brazil could ultimately cause a tornado in Texas. But how does this apply to our everyday lives? Let's break it down with relatable examples that will help you understand chaos theory and its implications. Who was Edward Lorenz? Before we delve deeper into chaos theory, let's take a moment to appreciate Edward Lorenz himself. Born in 1917 in West Hartford, Connecticut, Lorenz was a meteorologist who became fascinated by weather patterns and forecasting. In the early 1960s, while working on a computer model to predict weather, he stumbled upon something extraordinary. He discovered that tiny variations in initial conditions could lead to drastically different weather outcomes. This realization led him to develop what we now call chaos theory, a concept that challenges our traditional understanding of predictability in complex systems. His work opened up new avenues for studying not just weather, but also various natural and social phenomena, leading to profound implications in fields as diverse as ecology, economics, and psychology. What is chaos theory? At its core, chaos theory studies how complex systems can exhibit unpredictable behavior despite being governed by deterministic laws. This means that while the systems follow specific rules or equations, their outcomes can be highly sensitive to initial conditions. Imagine trying to predict the trajectory of a pinball machine. Even though the ball follows specific paths based on where it hits bumpers and flippers, small variations in how hard you hit the ball can lead to vastly different outcomes. This unpredictability is at the heart of chaos theory and illustrates the inherent complexity of many systems around us. The butterfly effect. One of the most famous concepts associated with chaos theory is the butterfly effect. This idea illustrates how small changes can have significant consequences over time. For example, consider this scenario. Imagine a weather model predicting a sunny day. If a meteorologist rounds off a number slightly, say changing 0.1234 to 0.1235, it might seem insignificant at first. However, as time progresses, this tiny change can lead to an entirely different weather pattern days later, perhaps turning that sunny day into a stormy one. This sensitivity to initial conditions means that in chaotic systems, even minor variations can create major differences in outcomes. It's a reminder that seemingly small actions can have far-reaching effects, both in nature and in our daily lives. Now that we have a grasp on what chaos theory is and its key concepts like the butterfly effect, let's explore some relatable examples from everyday life. Weather forecasting. We've all experienced how unpredictable weather can be. Meteorologists use complex models to predict weather patterns based on current data. However, due to chaos theory, long-term forecasts become increasingly unreliable because small changes in atmospheric conditions can lead to vastly different weather outcomes. For instance, a small change in sea surface temperature can affect storm paths and intensities. Traffic patterns. Have you ever noticed how traffic jams can suddenly appear out of nowhere? A small accident or even a driver hitting their brakes can create ripple effects throughout traffic flow, causing delays for hundreds of drivers behind them. This chaotic behavior illustrates how interconnected systems can react dramatically to minor disturbances and highlights the need for effective traffic management strategies. Personal relationships. Think about your friendships or family dynamics. A small misunderstanding or miscommunication can escalate into larger conflicts if not addressed early on. Just like in chaotic systems, these minor initial conditions can lead to significant emotional upheaval if left unchecked. Recognizing the potential for escalation may prompt individuals to communicate more openly and resolve issues sooner. Ecosystems. In nature, ecosystems are prime examples of chaotic systems. A slight change in one species' population, like an increase in predators, can dramatically alter the entire ecosystem's balance, leading to unforeseen consequences for other species within that environment. This interconnectedness is why conservation efforts must consider all species involved. Changes in one area can ripple across the ecosystem. Financial markets. The stock market is another chaotic system where small changes can lead to significant fluctuations. A single tweet from a prominent figure or unexpected news about a company can cause stock prices to soar or plummet within minutes, demonstrating how interconnected and sensitive these systems are. Market analysts often face challenges predicting short-term movements due to these chaotic behaviors, making it essential to adopt a longer-term perspective. Health trends. Consider how public health trends spread through populations. A minor outbreak of illness in one community can escalate into widespread concern if not managed properly, leading to panic buying or increased hospital visits as people react unpredictably based on initial reports. Understanding chaos theory is crucial because it helps us recognize the limitations of predictability in complex systems. While we may strive for certainty and control over our lives and environments, chaos theory reminds us that unpredictability is an inherent part of existence. By acknowledging this unpredictability, we can better navigate challenges and uncertainties. For instance, knowing that small changes can have significant impacts encourages us to be mindful of our actions, whether it's making decisions at work, nurturing personal relationships, or engaging in community efforts that influence social dynamics. In conclusion, Edward Lorenz's contributions to chaos theory have transformed our understanding of complex systems and their unpredictable nature. Through relatable examples from everyday life, from weather forecasting to personal relationships, we see how small changes can lead to significant consequences. Thank you for joining us on this exploration of chaos theory. If you found this video enlightening or have any thoughts about how these concepts resonate with your own experiences or understanding of unpredictability today, please leave a comment below. Don't forget to like this video and subscribe for more engaging content about science and human behavior. Let's keep exploring the fascinating complexities of our world together.